Hello guys, welcome back to the channel. This is Rosario Borgesi and in this video we will discuss the library Ethers.js that allow us to interact with the Ethereum blockchain. We will see how to transfer Ether to another account, and we will also see how to interact with the smart contracts. In particular, we will see how to write data to the smart contract and also how to read data from a smart contract. So let's get started. Ethers.js, it is a JavaScript library that allow us to interact with the blockchain programmatically, so by writing code, and allow us to avoid to make RPC calls to the blockchain, because in theory the blockchain exposes some endpoints that we can contact by means of an RPC call, but by means of Ethers.js, all this process is simplified and abstracted. So in this get this started page, there is a short introduction to Ethers, and covers it is a starting point for the people which are new to Ethereum, and covers the basic operations that we can do with the blockchain. So the first thing to do that I will do is to create a new to initialize the repository. So let's create a new folder, Ethers tutorial. Okay, so let's open a new terminal here. Let's start a new node application, npm init -y. Okay, so this way we have created a new Node.js application. And so the first thing to do is to install Ethers.js. So npm install Ethers. Okay, and other things that we will need, it is .temp. So npm install .temp. Beautiful. So now we can open our Visual Studio Code inside this folder. Okay, so we are here. This is our package.json. We can create a new src folder, and we put a new file called index.js. Let's also add here the type module. Okay, and now let's see if everything is fine by console logging. Okay, console logging, hello world. Beautiful. Let's now use this terminal here. Let's execute. Let's add also here a start, and you should execute node src/index.js. Let's see if it runs. So npm run start. No, start. Okay, hello world. So we have correctly made the setup of our application. Now we need to add a new .m file. Okay, in the root, where we put the info, the private key of our wallet, If you don't have, if you don't know what it is, how to set up a MetaMask wallet, please go see my MetaMask tutorial. And also we need an RPC URL, which can be, for example, there are many providers, like for example in Fura, you need to create the API key. You could also use Alchemy. This is the faucet, but here in the website of Alchemy you can create your own API key, or you could also use Base. Base allows also Base CDP. Sorry. So Coinbase Developer Platform. Okay, that allow you to create an API key that and especially the RPC node that we will use to communicate with the blockchain. Why do we need this provider? Because since we are not starting our own node, we need to contact a node in the blockchain in order to send our transaction or read the blockchain data. And so there are these providers that make at our disposal their nodes by means of an endpoint, so an API, and we can contact this node to execute our transaction against the blockchain. So once we get this RPC URL, we will put it here, and we have to choose an endpoint for Base Evolia. Let's get back to the documentation. So we have already installed the Ethers library, and now everything in Ethers is exported from its root, especially from the Ethers object. So to use Ethers, the Ethers method, we should make this import here. Let's also add the main. Okay. So also the other function are imported from this object here, Ethers. Okay, now let's move to discuss some common terminology. An Ether inside Ethers, a provider is a read-only connection to the blockchain which allows querying the blockchain state, such as account, block, or transaction details, query event logs, or evaluating read-only code using code. To create a provider, we can write const provider. Okay, here already it gives me the auto completion, but we need to import the RPC URL from the environment variable that we wrote in the .m file. So we need to import .temp, and we can just write import .temp /config. That should do the trick. Now we can write process.emb RPC URL, and that should work. So here we have imported the provider. Okay, Now what it is, so the provider, as we said, allow us to query the blockchain. So accounts, block, to get information about the block, transaction details, query log events, and or also evaluating read-only code using a call. Then there is a signer. A signer wraps all operations that interact with an account. An account generally has a private key located somewhere, which can be used to sign a variety of types of payloads. So the private key may be located in memory using a wallet object or protected via IPC layer such as MetaMask. So it is saying that you can have you can import a wallet, so you can interact with your MetaMask account, and this is for a front-end application from MetaMask. We will see how later on. Or you can interact with your account by using the private key, but you need to use a wallet object. So this is the object that is necessary when we want to use a private key. So instead of using the MetaMask extension. So to create a wallet, we can write, for example, const wallet equals to new Ethers dot wallet. Here already auto completes the code. So this is our wallet, and now that we have a wallet, let's recall what it is a transaction. So to make state changes to the blockchain, a transaction is required, which requires a fee to pay. So in the blockchain, we remember that when you execute a transaction, so you change the state of the blockchain, you have always a fee to pay. In fact, the fees cover the cost associated with executing the transaction, such as, for example, reading the disk and performing maths and storing the updated information. If a transaction reverts, a fee must still be paid, since the validator still had to expend resources to try running the transaction to determine that it reverted, and the details of its failure are still be recorded. Transaction include sending Ether from one user to another, or deploying a contract, or executing a state-changing operation against a contract. So this is the definition. This is what it is: a transaction. A contract, so a smart contract, is a program that has been deployed to the blockchain, which includes some code and has allocated storage, which it can read from and write to. So it is a program that it can be executed on the blockchain. So it may read from when it is connected to a provider, or a state-changing operation can be called when connected to a signer. So we can read from it with a provider, or we can call a state change operation, so a transaction on a contract, with a signer. That's why we need both a provider and a signer. So once a transaction has been submitted to the blockchain, it is placed in the memory pool. mempool until a validator decides to include it in the chain. A transaction changes are only made once it has been included in the blockchain, at which time a receipt is available, which includes details about the transaction, such as which block it was included in, the actual fee paid, gas used, all the events that it emitted, and whether it was successful or reverted. So here it says that to connect to Ethereum, the very first thing we need to do is to create a provider object, which we already did. There are two cases. You can use MetaMask here by using the window.eth, the window object, because you get this when you are interacting with the browser. So this is for front-end application. We are in a back-end application, so we will be using this JSON RPC provider. And in fact, as it states here, if you are running your own Ethereum node, it is not our case, or using a custom third-party service like Infura, Base, or Alchemy, we can use the object JSON RPC provider. And we can use also this JSON RPC provider when we are using local blockchain, like the one that is generated for us when we use Ardot to develop our smart contract, or with Ganache. So we already did this. Okay, we could also get a signer from here, but we have got the signer by using the private key. So another thing that is important to know is that in the blockchain there are only integer values. When interacting with Ethereum, there are no decimal values. So since then there is a workaround to use the decimals, because in order to use the decimals in Ethereum, we use very great numbers. For example, we never when contacting the blockchain, we never use Ether, but we always use Wei, which is as you can see, it is a very large number, because a Wei, to convert 1 Ether to Wei, we must multiply to 10 to the power of 18. There is also this other unit, which is G-Wei or Gigawei, maybe, that is 10 to the power of 9 Wei. So this is the way we interact with the blockchain, and since we want our value in Ether, we must, because we reason in Ether, we must convert these values. So for example, we have this method. For example, here parse Ether transforms automatically 1 Ether into this amount of Wei. Or for example, here this other method, parse units, parse units allow us to convert, for example, this amount in Wei. Okay, this amount of Wei into Wei. Okay, because when we must communicate with the blockchain, we must always send the amounts in Wei. We cannot use Ether. And okay, so we can convert from Ether to Wei, and from Wei to Ether. We can according if we want to show the information we are using the blockchain, or we are showing the information in our application. Okay, now that we have the provider, for example, we can use the provider to query, for example, the state of an account. We could also fetch historic logs and look up, for example, a contract code. For example, here we can try this operation here. For example, we can here we get the current block number. For example, we could write wait provider console const block number. So let's write also log. Let's console log this number. Okay. So the actual block number is this one. Okay, here. Perfect. Let's format this document. Let's run it. Okay. Here I'm missing something. So the actual error was that the auto-completion of GitHub Copilot put providers here which was not required. So this is, for example, if we run this code, okay, we can see that the actual block number is this one. For example, we could also say provider here get the balance of for example an address, which could also be an ENS. For example, you could write const balance, the balance of my account, this. Now let's see what prints out. Console log the balance of the account. Let's put this in a constant. Const account equals to, okay, here we put dollar count, and here we put also count. Let's see. This is the balance. It has it already. The auto completion is calling the format iter method. Let's see if it is the right method to convert. Okay, maybe it is. It has not been imported. I believe maybe it is just format iter. Okay. Okay, fine. Okay, so another thing that so we have seen how to query the state of the blockchain. We could also, for example, send a transaction, so send Ether to another account. So here it says to write to the blockchain you require access to a private key, which was what we did here. Okay, which controls some account. This is so I am using my account to send money. In most cases, those private keys are not accessible directly to your code, and instead you make requests by a signer, which dispatches the request to a service such as MetaMask. This is not our case because we are providing directly the the private key. So for example, if we can copy this code, okay, format the document. So we are sending a transaction of, for example, 0.001 Ether to, for example, my second account, which is this one. So let's copy it. Let's paste it here. Okay, very low amount of Ether. This is the receipt. Here we would also console log the transaction receipt is okay. This maybe we put here const okay, it's clear. Let's run this code. Okay, signer is not defined because this should be the signer. Okay, this we can comment out this maybe, because we don't want it to execute it each time. Okay, parse Ether is not defined. I should import it from here. Here I miss maybe the hash. Maybe this is this one. This is the transaction receipt. If I go to a block scanner, for example, here we can choose a block, scout, Sepolia, base. Let's find this transaction. Okay, success from my first account to my second account of this amount of Ether. So it seems that the transaction was executed. Always remember that when you send transaction, you always need the await. Always. Also, when you read, when you interact with the blockchain, either for writing data or to read the data, we always need the await, are always promise. So once this is done, so we have learned how to send, let's say, money to another account. I believe this can be closed. Let's see how to interact with a contract. Okay, so a contract is an object that means that is used to interact with a smart contract and is based on the API that it is passed, which then determines what method and properties are available on this smart contract. So the API is like a JSON file that describes all the variables and all the functions of a smart contract so that we can interact with it. It gets created when the contract is compiled in Solidity, for example with the Remix or also with Ardat. And so this is an example. So this is an example of creating a new contract. A new contract object. is not deploying a new contract, because this is the contract address, the API, and the provider. So we could, for example, interact with the smart contract of the wrapped Ether contract. Wrapped Ether contract, it is a contract that let's say that converts Ether, which is the currency of the Ethereum blockchain, to an ERC20. So it is an ERC20 that maps the Ether, and it is used for in the DeFi applications mainly, but it is a good example of interacting of a smart contract. For example, in the case of Base Epolia, the wet contract is at this address. So, for example, if you want to use again Block Scout, we can check this contract. Okay, as you can see, this is the wrapped Ether contract, which has this balance on Base Epolia, and it is an ERC20 that represents the Ether, represents the Ether money. Okay. Now, to interact with the smart contract, we can, for example, we should import its API key. I believe that you could also do you could also call this way the function, but since I have the full API key, I prefer to use it. So we could maybe we can make a test later on to call it with that other way of defining the API. So here I create a folder APIs, and I put here the JSON, this is the API of the wrapped Ether contract. Okay, as you can see here, I listed all the function. For example, we can call balance of, okay, or we could also call, for example, deposit. Okay, so one thing that we can do here, given that the address of this contract is this one, so we could create a new constant here with the wet contract address, and we can read the contract very easily. So we can say here, for example, const wet contract equal to new headers. Maybe I can also import here the contract object. Maybe also here we can import the wallet and JSON RPC provider. So we eliminate all this stuff here. JSON RPC provider. Okay, here we can put new contract. Okay, and here we put wet contract address. Then we need the API, and then we need the provider. Okay, let's see what reads from here. Let's run this again. Of course, the API is not defined because I have not imported it. So I should write something like here import wet API equal to from here we put dot slash APIs wet maybe wet dot JSON, and here maybe I need with type colon JSON format. Here gives me some problem where I use this, but it is fine for me. Here we need to put this. Let's see what happens. This is wet. Let's run again. Okay, seems that it has imported the contract. This should have been commented out because otherwise each time we run this it also remove this code. Okay, now let's say that we would like to call the deposit function of this wrapped Ether contract to deposit some Ether, okay, from my account, and this could be done for example in this way. Let's call here the let's create a new object transaction equals to await let's say signer dot send transaction. Okay, signer send transaction. Here we put data wet contract, okay, dot interface. Okay, this is right, encode function deposit. Here we are encoding the function deposit, and we have to pass the value, which are the amount of Ether that we want to deposit, which are for example 0.001. Then we can say from signer.address, okay, to wet contract address. That should be it. And then we should call here const receipt equals to await transaction to wait, and here we can console log the receipt this way. So clear. Let's remove this console log. It is not working. Let's run this code. Okay, this is the transaction receipt. If I go to block scan, I paste this transaction, I can see that the transaction was successful. I called the deposit method from my account, which is FE28, and here I have minted 0.0001 of wrapped ethers. Let's see more details what it has happened here. As you can see, here I have transferred this amount of ether. So my previous balance of wrapped ether was this one. This was this was increased by this amount here, and so my account has this amount of wrapped ether on the wrapped ether contract. Okay, because these are not ethers that are sent from an account to another, but we are interacting with a smart contract, so this smart contract keeps track of how much wrapped ether we have deposited. Okay, so we could, for example, also call the balance of function. I believe that in the documentation there are also other examples. So here, for example, is an example of a transfer function that has these two parameters. So it calls the transfer function with these two parameters here. Okay. Here, for example, it calls the balance of function from the contract. So we can call it, I believe, also this way. Okay. Decimals. Okay, this seems cool. I don't know if the wrapped ether contract has the decimals. Let's see. It should, because it is in ERC20. Okay, it has. This is a very cool code. Let's copy this. Let's see if it works. So, let's comment out this code. Let's get the balance of my account, which is account. The contract is wrapped ether contract. This can be eliminated. This can be eliminated. So let's see that. Let's see that we call this way. Format units. Decimals. But we don't have decimals here. We don't have decimals here, so here I can put maybe way. Or we can leave it also this way. It should do it the same. Let's copy the console log. Okay, let's see what happens. Format unit is not defined. Okay. Parse either format either. No, we used the previously format either. Okay, should be format. Yes, we used the format either. Format units is not defined. Okay. Okay, so we can remove this because we don't need it. This is a format either. This should work. Okay. The balance of this account, my account, is this one. That should be the same that we see here. No, sorry, on block scan. Okay, it's this one. And we could also see it on MetaMask. 0.3 zeros and 1 because it is approximated. Okay, so with the read-only method, this is an example of read-only methods. So when we are calling the methods that do not change the state of the blockchain. Here there is an example of calling methods that are changing instead the state of the transaction, and deposit was a state changing method while balance of not. We could also, for example, call these other two methods. Let's see if here there is that should be symbol. Okay, so we could also make this example here. We could also make it this way. So for example, here we could call symbol is this one. So const symbol. Let's console log the symbol of the token is a symbol because each ERC20 has a symbol. Then here we have also decimal. We could write, for example, const decimal. Wait, this is always obviously web contract. So we could console log the decimal of the token is this one. Then if we like, we could also console log the balance in that other format units. Okay, Ethers, comma decimals, decimals. Okay, let's see what happens. We are everything. Okay, so the symbol of the code token is wet. The decimal are 18. So the balance is 18 Ethers. There is something wrong here. Okay, because here was, I believe, this way. Okay, it gives the same result. And then there are also other things that could be useful, like listening to events, query historic events, sign messages. So thank you for seeing my video. I hope that it has been useful. If you have any questions or suggestions for the next videos, please drop a comment below and I will answer you as soon as I can. Thank you for watching and see you in the next video.